Good morning, Providence Chemistry. It's great to see you again. Psalm 116. I love the Lord because he has heard my voice and my pleas for mercy, because he has inclined his ear to me. Therefore, I will call on him as long as I live. God, we pray that you would be with our school, with our administration, with the students, teachers. We love you, Lord. Please help us. And the parents. Amen. Okay, what we're going to do is review chapter 11, just as promised before the break. So I'd like for everybody, if you don't have these materials right now, to pause this thing and go get them. Every day, when you sit down to listen to me, you're going to need a pencil, paper, packet for this chapter. After this, no more packets. A book and a calculator. Now, go get that stuff. Just pause me. Okay, welcome back. Now turn in your packets to chapter test B. Chapter test B looks like this right here. If you don't have it, just pause this thing and then get chapter test B and go to the back and find question number 30. I'm going to go 30 through 35, and then I'm going to give you some homework from the textbook that correlates with those 6 problems. And what you're going to do is you're going to see that right after my film on LMS. So every day you're going to do like a little testlet, I'm going to call it, 5, 6 questions. And you're going to be multiple choice, true, false, matching, that kind of thing. And so in the process of 3 or 4 days, we're going to review this entire chapter, and then we're going to move on. So I'd like to give you guys 3, maybe 4 testlet cuts. That's what I'm calling it. And so they asked us not to grade Friday and Monday, and I won't be doing that because I'm going to give you 3 cuts. But if you happen to get a good score on Friday and Monday, then you don't have to worry about it. You can use those cuts later on. Just your 3 lowest grades. Take them every time, and when you do these problems, do them yourself. Work them out, show your work, because every once in a while I will ask you to take a photo of your work and upload it into LMS for me. But right now you don't have to do that. Just answer the questions and it'll automatically feed into the grade book for me. Take good notes, and when you do these problems, after you've done them yourselves, then it's open game. You can discuss it with somebody else if you need to do that. Open book, open notes, open friend after you've done it yourself. Okay, number 30. You can see that on chapter test B. Convert 0.75 atmospheres into millimeters of mercury. So you're just going to write down what they gave you. And everybody knows, you can look in the book, you're going to see that 1 atmosphere of pressure is 760 millimeters of mercury. That cancels. And you're going to go ahead and multiply that times that, and you're going to get the answer, which is 570. Put a box around it, you're done. Number 31. You start writing down things that they gave you. Like the pressure of the sample is 200 milliliter. Oh, 2 atmospheres. And the volume is 200 milliliters. And it says we're going to go to 10 milliliters. Remember all this? And they want pressure number 2. Do you remember what the law that is? It's Boyle's law. P1 V1 equals P2 V2. Plug and chug. We're talking 2. You don't even have to convert it from atmospheres to something else. It'll just show that your answer is going to be in atmospheres. This is just a simple proportion, you remember that. The volume is 200. You don't have to convert that either. Pressure number 2 is unknown. And volume number 2 is 10. As long as the volumes are the same, you don't have to convert anything. If they're not the same, then you got to make apples with apples. You know how it works before you plug it in here. So that's 400, and we're going to divide both sides by 10. 400 divided by 10 is about 40. And the unit is atmospheres. Put a box around it, and you're done. Number 32. The volume of a gas at 7 degrees Celsius is 49 milliliters. And the 7 is the temperature. You got to add 273 to convert it into Kelvin. Just cross that off because you're not going to get confused that way. And the volume goes up to 74. So they want to know probably what the new temperature is. And they do, keeping, of course, the pressure constant. This sounds like Charles' law, if you remember. So it's V1 over T1 equals V2 over T2, or vice versa, as long as you switch them both. V1 is 49. T1 is 280. V2 is 74. And T2 is T2. Cross multiply, 49 times T2 is equal to 74 times 280. Now divide by 49. And you're going to get a number of, for number 32, you're going to get 150 Celsius. So let's go ahead and multiply that out on our calculator. And you'll see that you don't get 150 Celsius. And I think some of you may already know why. 74 times 280 divided by 49. That gives you 422.85. The temperature is 422.9 Kelvin. So in order to get it back to Celsius, to get an answer like it looks in the book, you got to not add, because you add when you go from Celsius to Kelvin, but you subtract when you're going from Kelvin back to Celsius, 273. And when you subtract 273, you're going to get your answer of 150 degrees Celsius. Round it off. Okay, moving on. That was number 32. So let's go 33. 33, we get pressure of 70 liters. I got to make some more space here. Okay, pressure is 70. Liters. Oh, that's not a pressure. That's a volume. Liters are volume. The pressure is 600 millimeters of mercury. At 20 degrees, that's the first temperature. This looks like it could be a combined gas law problem. Temperature drops to 15. And the volume goes to 90. And they're all in the same units. That's nice. What will the new pressure be? Well, that's, let's see, PV over T equals PV over T. And just plug it in. 70. P1 is 600. You don't have to convert anything. T1, 293. P2, unknown. P2, 90. And T2 is 288. Okay, now we're going to go ahead and multiply, cross multiply, boom, boom. And so we got 600 times 70 times 288, and that equals 293 times 90 times P2. Reverse the order there a little bit there for you. 293 times 90 is what I'm going to divide both sides by. And we're going to cross it off over here and have P2. When I do that, I'm going to go like this. 600 times 70 times 288 divided by 293, further divided by 90. And I get 458.7. And it says 459 millimeters of mercury, just like I'm supposed to. Number 34 is just like number 33. It's a combined gas law problem, so I'm not going to do that one for you. Number 35, let's just write down what they gave us, like I always do, and then pick the appropriate equation. 35, the mass of a 1 liter sample, that's volume number 1, is 0.716 grams. They don't tell you what it is, just a gas. At STP. STP, what does that mean? Standard temperature and pressure. So standard temperature is 0 degrees Celsius. At 273, you got to have Kelvin for all these gas laws. And you're going to get 273 K. Okay? And standard pressure is 1 atmosphere. Okay, that's just memory work there. It says, what's the molar mass? Capital M. Well, you can see that there is no second volume, there is no second temperature, and there's no second pressure. So this is not a combined gas law problem. This is PV equals N R T. This is an ideal gas law problem. Now, I told you in class that the number of moles, like for example, if I gave you 24 grams of carbon atoms, how many moles would that be? Well, 24 divided by 12 off the periodic table will give you 2 moles. So the number of moles, this thing here is actually the mass they give you divided by the molar mass. Now the pressure is 1 atmosphere. The volume is 1 liter. A lot of ones. The mass is 0.716. And the molar mass we don't know. And R is 0.082 out of your book. That's a constant, a proportionality, a gas constant. And it's that number if the pressure is given in atmospheres and the volume is given in liters, which it is. Of course, temperature will always be in Kelvin, 273. Now, what do you do with that? Well, you cross multiply. You see there's an invisible 1 down here. So mass times 1, which is mass, is equal to 1. So here we go, bump, bump. 1 times all of that. Now, these will not always be 1 over here. So you might have to divide this to see 1 times 1 is 1. You might have to divide this by whatever number is times m, of course. And you do that to both sides. But since it's 1, you don't have to do that this time. And so just multiply those numbers together. And you're going to get, for number 35, you're going to get 16 grams per mole. Box around it, and you're done. That's the molar mass. Be sure to do those problems online. See ya.